So if the universe is expanding, what's it expanding into? Well, right off the bat, we could acknowledge that perhaps this question doesn't actually make as much sense as it sounds like it does. It's a good question because when we think of an expansion, we picture something growing into a larger space. And it doesn't help that the analogies used to explain expanding space, like dots on an inflating balloon, while helpful in many regards, are imperfect because they lead to this line of thinking. Like the balloon is getting bigger within a larger space, and if the universe is somehow similar, what is it getting bigger relative to? But the universe itself, as defined as the totality of all that there is, isn't expanding into anything. It's everything. And it's just expanding as one of its intrinsic properties. To ask what is everything expanding into, what's outside of everything, may just be a question that doesn't really have an answer. Something similar to asking, how do I go further north when you're directly at the North Pole? But what if the universe isn't actually everything? What if there is an outside of the universe? Well, to go down that road, we need the answer to another question. Is the universe infinite? Does it literally go on forever? Or is it finite? Does it have a limited volume? We don't actually know the answer to that question, and unfortunately, we may never truly know. We are, after all, confined to the observable universe. We can only see as far as light has had the time to travel to us. What lies far beyond the observable horizon may truly be an unanswerable question. So let's entertain both options. If the universe is infinite, what's it expanding into? Nothing. It's everything. In a sense, it's expanding into itself. If it's infinite, it remains infinite as it expands. Infinity is mind-bending, but here's a way to think about that. Imagine a number line to infinity. Now space those numbers out from one another uniformly. You haven't created more numbers, you've just expanded the number line. There was an infinite amount of numbers before and after, just as space would be infinitely big before and after expansion. But what if the universe is finite? What's it expanding into? Well, this is where it gets interesting, and I need to lead with the fact that speaking with any certainty on the matter would be misplaced. Again, we can't know for sure, but we can speculate. Does a finite universe mean that there's some sort of edge or tangible boundary somewhere that goes from universe to non-universe, entering into some possible void of literal nothingness? Or perhaps a multiverse with endless other bubble universes? Can't say for sure. We can, however, say that according to Einstein's general theory of relativity, our best theory of gravitation and the nature of space-time, 3 different possibilities for the geometry of the universe are allowed. And a finite universe would have what's called a closed geometry. It would be finite in the same way that, say, the Earth is finite. In that, if you were to travel in a straight line long enough, you would just wind up back where you started. Similarly, if you traveled through space in a straight line and never stopped, you'd watch as the Milky Way galaxy receded behind you, and after some unimaginable time, you'd see the Milky Way approach in front of you once again. There's no direction you could go or anything you could do to get outside of the universe because there wouldn't be one. And as a finite universe continues to expand, the journey to get back where you started just takes longer and longer. So even in this case, the universe wouldn't be expanding into anything. Now, talking about lapping the universe like that is only to describe how the closed geometry would be. Actually doing that would not only be impractical for obvious reasons, it would actually be impossible, because beyond a certain distance from us, we know that the expansion of the universe exceeds the speed of light. But nothing can possibly travel faster than the speed of light, right? Well, that's a discussion for another video.